Hello everyone, I think we will start at around 8:05 to make sure that everyone will arrive and has arrived. Yeah. everyone. I hope you guys can hear me. Welcome. My name is Regan or Tan Wan Lun. I'll be tonight's event's host. I am the co-lead for GDSC Monash Malaysia. So I would like to extend a warm welcome to everyone here, who took their time out of today evening, to attend this workshop. So first things first, I would like everyone here to rename themselves to their full name or the name that they've used to register for the GDSC event. So the purpose of this is because we have to check in everyone who registered to our event, to check our details and demographic and all. So I hope that you guys can, help in renaming yourself in this Zoom meeting. Yeah. And another thing here is according to follow our university's protocol, we would also like everyone to register to fill in a form basically as an event registration. So it involves filling in like your basic details and such. So I'll send you can scan the QR code here, which is the event registration form, and I will send a link in the chat right now. And another thing is for any questions, we would for any questions throughout the workshop today, we would appreciate if you guys can answer in the Slido Q&A instead of the Zoom chat meeting, because we have moderators to help clear and answer all your questions and such. So yeah, here is the whole link for the event registration as well as the Slido. So yeah, we really appreciate if you can fill in the event registration form, and if you have any questions, just go to Slido and you can ask whatever you want. Yeah. So without wasting everyone's time, I will pass it on to Zaima, our tech lead, to start the workshop. So thank you everyone for joining, and I'll pass it on.
Thank you. Is my audio all right? Can you hear me?
Yes, it's on.
Okay, cool. So we can get started. Before we start, I just want to let you guys know that this is a two-part workshop. So our first workshop will be on Flutter front end, and our second workshop will be on Flask backend. So during this workshop, you'll learn the Flutter basics, and the coding session will teach you about the Flutter front end. And during our next workshop, we will be continuing our code to create a Flask backend that you can integrate along with your app, so that you guys will learn how to create a front end and back end along with integration. So we can get started right now. I will send a link at the end of the workshop so you can register to our next workshop as well. So hi everyone, my name is Zaima. I'm a third-year software engineering student here at Monash, and I am also the tech lead for the GDSC Clubs Monash. So today I'll be the speaker for our Flutter workshop. So let's get started. So Flutter is Google's UI toolkit for building beautiful natively compiled applications for mobile, web, and desktop from a single code base. So it's a UI toolkit that uses the Dart programming language for building native apps for multiple platforms. So one of the key selling points of Flutter is that since everything is built from a single code base, you can actually create your prototypes for multiple systems, such as Android or iOS, without requiring specific developer knowledge about each platform. So let's take a closer look into what Flutter actually offers us. So let's start with beautiful custom UI and animations. So what you're seeing here are some UIs created using Flutter. So yes, they are quite pretty, but as a developer looking at this, it seems like it would be a nightmare to create. There are so many components, so many moving items. Believe it or not, using Flutter, well, I wouldn't say it would make it easier because it is quite a complex UI. I mean, I wouldn't say it would make it easy, but Flutter can greatly reduce some of the complexity and the time that would be taken to create something like this. So it makes it a whole lot easier and faster. Now, while Flutter isn't the only tool that can actually work cross-platform, it is designed from the ground up specifically for creating apps. So, which is why it is usually a popular choice for rapid prototyping or hackathons, for example, like the upcoming Google Solutions Challenge, because it allows you to create apps quickly. So it's also able to easily tie into device hardware using external plugins and packages that can easily be imported into your project. It also uses widgets, of course, its main feature, which we'll be digging into a bit more soon. So this allows it to create UI components programmatically rather than requiring something like a layout file or a storyboard. So it is also open source and it has full documentation. So this is something really cool about Flutter. It is completely open source. So not only is Google working on it, but there are also so many members of the developer community. So, rather than being walled off from the internal workings of the tool, you can actually dig into the code to see exactly how Flutter is doing what it's doing. And you can even send your own pull requests if you want to improve it. So far, there have been about 22,000 contributions from the global developer community into Flutter, and that number just keeps rising as more and more people discover and try the platform. To give you an idea of how fast this is really going, there were about 18,000 contributions just 6 months ago. Now, I'm not sure how old this statistic that I've got is, but I'm sure that there's a whole lot more today as more people discover and try out this platform. Let's also talk about documentation. So personally, I hate reading the official documentation for most languages, and I honestly much prefer watching YouTube videos. But I'm actually a huge fan of what the Flutter team has put together, especially since a lot of it isn't just, the standard, this component does something. So one of the things they have is a Flutter cookbook, which is actually a documentation page. It contains various code samples or recipes for common tasks that you might want to do in Flutter. There's even a whole GitHub repository with folders containing sample code on some specific tasks that you may want to do in Flutter. And this is just a sample of what's there, but you can see that it's a lot of great content that you'll use in almost any app, such as animations, design elements, networking, and navigation. So I'll have Yishan put the link in the chat for this. Please do check this out if you're diving into Flutter, because it's an extremely useful resource. And it's actually something that I referred to multiple times. It's really well put together. There is also something called hot reload, which is used a lot during rapid prototyping. So another feature that I think is super valuable in Flutter is this hot reload. So this means that you don't need to restart your entire app for small UI to test any small UI changes. So instead, UI changes will automatically be applied in your running app as you change various values. So as you can see in this image over here you can simply change your code and save it. And then you can automatically see the changes applied in your running app as you change these values. So you don't actually need to restart your entire app. So this makes it really useful when you want to do some rapid prototyping and test out some different features. So you can see here, if you watch this video, you can simply you can increment your counter and change it. You can change this to tapped, simply save it, and it will automatically restart. It will automatically rebuild that widget, which means you don't have to restart your entire app, which saves a lot of time when you just want to test small UI changes, for example, during rapid prototyping. Another thing about Flutter is its multi-platform nature. So we've all seen apps that have been made with multi-platform tools where they just don't look quite right compared to, the system standard UI, such as Android apps that look like they were designed for iOS. So what makes Flutter particularly handy here is that it is actually able to tell what platform it's on. So you can apply the proper UI elements for your app based on your operating system. For example, over here, so an app can be single platform or cross-platform. So with single platforms, it's enough to simply create a native application, but most of the time you would want a cross-platform, which is when you can either have to do, for example, 2 native applications, maybe for Android and iOS, or you can do a hybrid application. And these come with their own sets of challenges. So with native applications, they are quite high quality and they also have high performance. They are quite fast and responsive. However, you will need to develop more than 2 apps for different platforms, for example, for Android or iOS. So this can lead to inconsistent animations and features between the apps that have been built for these different platforms. While with hybrid application, this is actually, you can get fast development, especially since it's from a single code base, which makes the development process a whole lot easier. However, it has poor performance, and it also has non-native features and appearances, such, like I mentioned before, an Android app that looked like it was designed for the iOS. So how does Flutter come into play here? So Flutter does not actually let the platform render the app. It does it itself. So this means that it's quite fast and responsive, regardless of whichever platform the app is running on, because it can run on any platform. There's no bridge needed between the app and the platform. So it only requires Canvas, which is used to render widgets to appear on the device screen, as well as events, such as finger taps and device services. So this image right here, it's not really essential for you to know all of this, but just for your information, I put it here. So as I mentioned before, Flutter is a UI toolkit, and it uses the Dart programming language for building native apps for multiple platforms. And it does this on top of C++ or C, using a 2D engine called Skia. Now, this is the same graphical engine that's used by Chrome, Android, and a few other platforms. And this is all from a single SDK. So again, since everything is built from a single code base, you can create your prototypes, multiple systems without requiring specific developer knowledge about each platform. So over here is the platform embedder. So this is a small platform specific layer that integrates into the Flutter engine. It integrates the Flutter engine with the host operating system and the hardware. So this is what actually provides the bridge between the Flutter framework and the platform that it's running on, the platform's native components. Yeah, and just to summarize, the problem is that many apps need to run on multiple platforms, and Flutter allows us to do this without compromising on performance, quality, and speed, while still allowing us to build our apps from a single code base. It does not rely on OEM widgets. What OEM widgets are, they refer to widgets that are provided by the original equipment manufacturer, which is what OEM stands for. So it's the original equipment manufacturer of the device, such as Apple or Google. Flutter uses its own widgets so that it is not platform dependent. So there is no bridge needed between your app and the platform you're running on. And now on to the main feature of Flutter, which are widgets. So when you're working with Flutter, everything is a widget, and all UI is described by widgets in a tree structure. And I'm not really exaggerating when I say everything is a widget. So for example, if you want to add some text, that's a widget in itself. If you want to center that text, you need to wrap it in another center widget. You want to add padding, you got to wrap that in a padding widget as well. So what this means, so this is what we mean when we talk about a widget tree. It's essentially just a bunch of nested widgets, which eventually forms the tree, which is going to display our UI for us. So one key term that you'll see in Flutter documentation around this is called aggressive composition, which essentially means that aside from some very basic widgets, the widgets that you use in your apps, so either custom ones that you put together or ones that come built into the platform, this will be made from other widgets. So you can think of them like Lego blocks, where you simply connect them together to build whatever you want. And you can see here that there are two types of widgets. We have stateful widgets and stateless widgets. So a widget by itself is a stateless widget, while a widget that has its own state is a stateful widget. And of course, widgets look different when rendered on iOS or Android devices. So they will be Cupertino or material components respectively. So we'll dive into these a bit more in a little bit on what exactly stateless, stateful, and states mean. So what is a state? So states are stored in a state object class. So the state object class consists of values that can change. So for example, slider values, which when you change the slider, you get different values. So according to what the user does. For example, whether a checkbox is ticked. And when these states are changed, we call the set state method. And this is what informs Flutter to redraw the widget. So for example, if we want the UI to change once a checkbox is ticked, we can simply call the set state method, and this will allow us to redraw that widget and thus rendering the change on our UI. And so what are stateless widgets? Basically the opposite. These are widgets that never change, so they're static. This can be icons, text, images, etc. Basically anything that has no need to change and will never change. So in order to create a stateless widget, you simply extend the stateless widget class. And now stateful widgets, as we mentioned, they are implemented by a subclass of state, and they are also implemented by a subclass of stateful widget. So these stateful widgets are dynamic widgets. So these widgets are the ones that can change according to a user interaction. As I mentioned before, text field, forms, checkboxes, sliders. These are things that can change as the user interacts with the UI and the widget. So it implements two subclasses, stateful widget as well as state. And what happens is that stateful widget creates the state for us, which returns the mutable state for this widget. So as I mentioned, state is what stores our stored value, our changing values. So this will become a little bit more clearer once I show you some code, but this is just the basic idea. So let's look into some code here. So it's pretty simple. If you want to set up your first Flutter app, you can simply do Flutter create and then the name of your app. Navigate into your folder and simply do Flutter run. And this will run the entire Flutter app for you. Okay. Now what you see here, what you see here is the basic code that is pretty much always included in your main.dart file. So this is the main file, which is sort of the entry point into your app. So as you can see here, we have a main function, which actually creates your app. So the run app method is pretty self-explanatory. It simply runs your app. So it takes in a widget, which is your app in itself. So your base app, basically your entire app is usually going to be a stateless widget, which is why we extend the stateless widget. So over here, this is just basically some boilerplate syntax, some boilerplate code that is just always here. So the colon is the same as the equal operator in Java or Python. And this is just a constructor for our my app class. So the curly braces here means that this parameter is optional, and the question mark means that the variable can be. So this key parameter is usually not actually declared when we're creating an instance of the my app class. So in general, you only need to specify a key for a widget if you need to be able to differentiate it from other widgets of the same type. So the super keyword over here refers to the parent class of my app, which will be stateless widget. So this super key line is actually passing the key parameter to the stateless widget class, says constructor, so that it can use this key to be able to differentiate between different instances of this particular widget. Now, you really don't have to memorize any of this. This is the basic code that is used for every main.dart app. So when you create a Flutter package, this code is actually added in for you. So you really don't have to look too deep into this. So lastly, we have the build method here. So build describes the part of the user interface represented by this widget. And this is always going to return a newly created widget. So in this case, this widget will actually be our My App, which we're running. So here is where your whole widget tree you start building. And for your information, the build context is it just contains information of the location of this widget in the tree. You don't have to bother with this because Flutter automatically passes it in for you when you're building your widgets or your widget tree. Okay, and as I mentioned before, this is just the widget catalog. There are hundreds of widgets out there. So whenever you're building your app, you can just come here and check. Most of the time, they will probably have a widget for you that will be able to achieve the functionality you want. So just take some time and look through this widget catalog. The link is right over here, and I think Eugene can share it in the chat. Okay, now let's talk a bit about the widget trees. So widgets are nothing but elements of interaction which allow the users to interact with it. So once an app is loaded, Flutter is going to ask the widgets that it has for its associating elements, which is what it loads into the element tree. So ultimately, this element tree is what gets displayed in your UI. So this widget tree actually holds configuration and state information. So any state values is stored in this widget tree, and it uses that to render the UI, to render these widgets basically onto our screens. Okay, so material app widget. This is going to be the starting point of your app. It's used as a starting point of your app because it introduces a number of widgets such as scaffolds, navigators, themes. And you can see here that where you saw this run app method in the previous slide. And in the previous slide, we're simply passing in the name of our widget and declaring it over here. You can also directly create your widget within the run app. It's the same thing, but convention is to do it separately, as this is just better practice, especially when you're building large apps. So we've just put it here for demonstration purposes. So with the material app, you can declare a home, and the convention again is to set down a scaffold. So a scaffold basically is just something you set down on the page that allows you to add more widgets on top of it. So with the scaffold, it's going to give you access to an app bar, which itself takes in an app bar widget. And here you can declare your title, which here is going to be home. Something that I want to mention is if this sort of layout is confusing you, like the name, like home, scaffold, essentially what all of these are simply parameters. So material app, it's like we're declaring a material app, and then these are its parameters. Home is one parameter, which then you pass scaffold. App bar is a parameter of scaffold, which takes in an app bar widget. So you can really see how this widget tree is starting to get built as a bunch of simply nested widgets. Okay. Again, material app, you can add a bunch of things like the theme, we can set the brightness, primary color, etc. And the scaffold widget, as I mentioned before, is usually the top level container of a material app. So you would have a material app, and the top level container of that would be a scaffold by convention. So this scaffold is the framework for basic material design implementation. So what is material design implementation? So basically, material design app structure, it just refers to a design language that is developed by Google. So it provides guidelines for the visual, interaction, and motion design of apps. So it's just a basic design language that allow us to provide a consistent and recognizable structure for apps which makes it easier for users to understand and use them. So this just allows us, the scaffold just allows us to get a bunch of basic functionality that you will see in most apps, like app bars, drawers, sidebars, things like that. So over here, we've set down a scaffold. Again, we've added an app bar, a body with welcome to Geeks for Geeks. Text, we can set style, which is in itself a text style widget, and all that. So yeah, basically everything is a widget here. As I mentioned, you can add a bunch of things to the scaffold. A lot of basic functionality comes with this that you would see in any app, which is pretty useful, like app bars, buttons, drawers, navigation bars, things like that. So there are a bunch of things that you can add to this scaffold. So now the difference between material apps and scaffold widgets. So the material app is a widget that introduces a number of widgets, such as navigator and theme that I showed you, that we require to build a material design. So the reason that it's a common convention to return a material app as our root widget whenever we're running an app. The reason we do this is that it's because it provides a convenient way for us to be able to set up the visual design for an application, like the themes and the navigator, things like that, which allows us to build this material design app, which provides us with consistent and recognizable structures. And this scaffold widget is used under the material app. Usually it is designed to be the single top level container, as I mentioned. So it gives you a bunch more basic functionalities like app bars, navigation bars, drawers, buttons, etc. And it is designed to be the top level container, but it is not necessary to nest a scaffold. So you can instead put something else right after your material app. This is just the convention, and it just makes life a whole lot easier because it gives you a lot of convenient widgets to use. Yes, so let's go into stateful widgets because this can be a bit tricky for some people to understand. So as I mentioned before, it extends two subclasses. We have the stateful widget subclass and a state subclass. So the stateful widget subclass over here, it does not really do much. The majority, well, almost all of our code is going to go within our state subclass because this is where we store any of our, changing values. So what we do here within the stateful widget is that we simply create the state. So create state just returns to us our state object, which here is going to be my state. And by separating this mutable state object from our widget, Flutter is actually able to optimize the performance of the user interface because it's only going to rebuild widgets that have changed. So this means we don't have to rebuild our entire widget tree and rebuild our entire screen. We're simply going to rebuild the widgets that have actually changed, which really optimizes and increases the efficiency of our app. So if you take a look here, this is the simple build method, which builds our entire tree for us. So what happens is that when we click this button, we want the color to change. So on pressed, we call our change color method over here. And as you can see here, within this, we're calling the set state function. The reason we have to do this is because once we click the button, what's actually happening, if you look here, is that we're changing our container color variable to red or yellow, depending on what it was prior to this. So if we weren't calling set state and we weren't rebuilding this entire widget tree, then we're not actually going to reflect the change in our container color variable. So yes, once we press the button, our container color will change to red. But since we're not actually rebuilding this and showing it on our screen, it's not going to actually change. So this is why we need to call the set state method. This set state method is what happens is that it runs all of the code here, and then it's going to call this build method. This build method is going to rebuild whatever's in here. So the widget in here is going to be rebuilt, and as a result, we'll be able to see the changes on our. So I hope that was clear. Yeah, so as I mentioned, there are a bunch of widgets available. You can check them out and experiment with them while you code. You could just have it open on a window while you code, as there are a lot that will greatly reduce the amount of time you spend developing. So you can check them out from this link over here. And we can move on to the coding session now. I'm just going to check out if there are any questions first. You guys can post your questions on the Slido. So there is a question here. Can you connect Flutter with external API? Yes, you can definitely do that. There should be, I remember that I actually had to do this for something, and you should be able to find some documentation on this online on the Flutter documentation page that I told you about. Can individuals learn Flutter without prior coding knowledge or experience? Yes, you should be able to. It's not that complex. If not, what programming language do you recommend learning for absolute beginners? For absolute beginners, maybe you could start with Python. You could start learning with that. And Flutter actually uses Dart, which, well, all programming languages are quite similar in my experience. Like, it's just basically syntax that you should learn. Yeah, it is possible to learn Flutter without prior coding knowledge in my experience. You can just start learning the Dart language, and that will allow you to use Flutter. I believe there is a way to, you can get the, if you're developing on your laptop, which of course you're probably doing, you can, there's sort of a file that you can get onto your phone, which will allow you to view this. Otherwise, you can always use an emulator using the Android Studio, which will like show you a phone, and it will reflect the changes you made. So you don't have to actually get a physical phone to debug. But at the end of the day, you can, I'm pretty sure you can definitely get it onto a phone. I think we can move on to the coding session right now, and I'll answer a few more questions after that. So I hope all of you were able to download Flutter. Okay, so I will be using the VS Code IDE for this. And I suggest that you guys download the Flutter and Dart extensions. They're pretty useful. So this is the Flutter extension. And this is the Dart extension. So they have a bunch of useful functionalities. I'll show you some of them during our coding session. Okay, so I'm just going to open up. Oh. Okay, so I'm going to open up a command prompt so that I can create my Flutter package. And I'm going to navigate to the folder. And as I mentioned, to create a Flutter package, you simply do Flutter create and then the name of your package, which for our case will be Flutter. Okay, and then it is going to make a Flutter package for us, which we can then open in VS Code. And it's going to give us a bunch of files. Most of these files are not really important. I'm sure they all have their functionality, but you mostly have to just bother with the lib. So this is where we're actually going to add all of our Dart files. And the way you would run this in VS Code. So as I mentioned, as you are building your Flutter app, you have to display it somewhere, obviously. So you can use an emulator, or a much simpler way is via VS Code. You can select the device you want to use. So I would usually just show it on Chrome. And here Chrome is the device we have selected, which will be where our page is rendered for us. And as I mentioned, once you create a Flutter app, they're going to give you a main.dart file. And this will have a really basic app. And the way you can run this, you can either do Flutter run, or a much simpler way would be simply to do run and then run without debugging. So I know you would probably use this play button over here. This button actually is not going to run our entire Flutter package. It's just going to try and attempt to run a single file, which is not going to work, which is why I use this. So this is going to take some time. So I'm just going to go through the code that has been given to us automatically in this file. So as I showed you in the slides, we have our main function, which is our entry point to our app. And the run app method is, as I mentioned, it's simply running our app. Here we're passing in a my app, which is our app, which is a widget. And the super dot key, just basic constructor with an optional parameter, which is just going to be the standard thing you're going to do. So here is our build function. As I mentioned, we usually return a material app as our root. We have a title. Here we've added a theme as well. We can add colors here. And over here, we're passing in an over here, we're passing in an additional widget. So this is how you pass widgets between widgets. So for example, I want to be able to display this page here within my widget. And the way you do this is simply by declaring your class. So here is where we put it in our widget, and we also added a constructor. So you simply declare your class over here and pass it to code. And that's really all you have to do to add a widget to a different page or to a different widget. So as I mentioned, this is a constructor and these are optional parameters. So adding these curly braces, as I told you, will make it optional. And we add the required keyword here to specify that we want this title to be a named parameter, but it's not optional. You have to pass it. And this is the way how we pass variables between widgets. So you simply pass it through their constructor. So as you can see here, title is one of my parameters, and I am passing it here when I declare my home page. I am passing the title through that constructor. And I think our page has loaded up. Yes. So put this on the side. And here is the basic app that you get whenever you create a new Flutter package. So I'm just going to walk you guys through this because it's pretty good for understanding how this works. Okay, so this is a stateful widget. The reason this is a stateful widget is because if you see this, whenever we press the button, the text widget over here is going to increment by 1, which means that whenever we press the button, we want this widget to be re-rendered. So as you can see, we have two subclasses. We have the stateful widget and the actual state. So over here, we're creating a title variable, which is basically for this title. And the create state method is the function that will simply create for us this state, which is my homepage state. If you're wondering why there's an underscore behind this, it basically means that this is a private class. You can't pass it between pages, which is normal. What you want to pass is this class, the stateful widget. Okay. Sorry. So we're going to declare a counter variable, which is what's used to keep track of this value over here. And here is my build method. Yeah, so this is the build method that is building our entire page for us. So we're simply setting down a scaffold. Remember, we already set down a material app here. So the scaffold is going to be a child widget, which we've declared over here and passed into the home from. Okay, so this build method is creating for us an app bar. We're also putting the title here, which remember we got from the previous widget. This variable was passed to us through here. And the way we call it is simply by doing widget.title. We can then add a column widget, which we're going to use later, so I'll explain it later on. But it basically allows us to align it down the middle of the page. Okay, so what happens here is that what this is saying basically is that when we press the button, we are going to call our increment counter function, which is over here. And as you can see, our counter incrementing by 1 is done within a set state method. So again, the reason this is done is because once we increase our counter variable by 1, we want this change to actually be reflected on our page, which is why we put it within the set state method. And that means that every time we increment this set state is going to increment our counter and then rebuild everything that is inside here. So it's going to rebuild our widget tree for us. So that is the really basic app, which shows you a bit about how stateful widgets work. So we can start creating our actual app now. And I'm going to start by creating a to-do item.dart file, which is going to represent each task. So I'm declaring a class, which I'm going to call to do item. And I want to be able to have 3 variables for each to do item. I want an ID, an item name, and an is executed variable, which is a Boolean, which tells us if this task has been done yet or not. So here's the ID variable, which I am going to set to dynamic. So dynamic represents a value of any type. So this is used when you don't know the exact type of the object during compile time. Or it can also be used when you want to opt out of type checking for any particular expressions. So let's create an ID and an item name, which is going to represent the actual task name. Then a Boolean of is, sorry, it's actually in dark. Okay, we can then create the constructor. So we've seen constructors a bunch of times. I'm going to put some curly braces here to indicate that these are optional parameters. Choose our ID, this dot item name. This is the keyword. This is a pretty common thing you use in class constructors, just to let you know that this variable is for this specific class. And then this dot. So while ID is a dynamic variable, because we will be automatically generating these IDs by using the Flask service, item name and is executed cannot be dynamic because we want the user to pass us these when they're creating a task. So what you can do, there are 2 functions of the curly braces. 1, it makes the parameters optional, and 2, it makes them named parameters. So if you want to have a parameter that's named but is not optional, you can simply add the required keyword. This means that the user is required to pass in these items. Okay, we can now move on to our main.dart file. And actually, a lot of the code is already here, because as I mentioned, the main.dart file is usually just a bunch of basic code, and to that is where you actually pass in your widgets from different files. So I'm going to have this side by side so you can see it. Okay, so I'm just going to start by, so I still want the material app to be our root. I'm going to start by removing this debug banner here, just to make it look a bit better. This is just some pretty basic things that you would do whenever you're starting off. So you can set it to false. And you can see the hot reload functionality that I'm talking about by simply saving it. And then, as you can see, it's gone now. We can set our title. We can keep it as Flutter demo. Our theme, let's change it to purple. And let's keep all of this, because this is just something basic that you want it to be there most of the time. Okay, we do not need this counter. And I'm going to remove everything in here and redo this. Okay, so as I mentioned, I want the scaffold to be right underneath the to be the top level container of our material. So we'll this. And now I'm starting off with some basic functionalities. For example, what I'm going to do here is resize to avoid bottom inset falls. What this does is resize to avoid bottom inset is some functionality that allows us to, when you have an app and you want to type something in, so the keyboard pops up, right? And what happens when this keyboard pops up is that you want all the items on the top to resize so that it doesn't look funky, right? So since this is just a simple app, I'm going to set this to false. And we're also going to specify our app bar and pass in an actual app bar widget. Okay. Okay, over here, we can add the title, which is going to be the text that was passed into this widget earlier, this title over here. So as I mentioned, to get the text, you go widget dot. And I also want this title to be centered. So I'm just going to do center title. So it is. Okay, so let's take a look at this. Yeah, so there it is. Just pretty simple, just an app bar and some text. Okay, we can now move on to, I want to have a task input field over here along with an add button. So we can start on that by creating a new file. And let's call it tasks. So this widget will display the task input field as well as the add button. So with this code, clicking the add button is going to, well, I'll show you. So you want to start by importing this specific package. So this package is called, it should show up here because it's a package that you use quite a lot in Flutter. So this is called the material dart package. And what this does is that it is used to bring in definitions and classes from the Flutter material library. Now, this provides a set of customizable material design style widgets. As I mentioned before, material design style is just a design language made by Google. So we can bring in these widgets, which allows us to build this really nice responsive user interfaces within Flutter. So after I import it, we can start by actually creating our task widgets. So here's a trick that you can use. As I mentioned, stateful widgets and stateless widgets, they all have a pretty basic format that all of them follow. So instead of having to type this out over and over again, something that you can do is simply state stateful and then click on tab, and it's going to write this out. And it will also allow you to just change the name of your widget, which I'm going to set to tasks. And it will change it all. And the reason I want this to be a stateful widget is because there's going to be a lot of changes. For example, when the user clicks the add button, I want it to be added to the database. When a user clicks the delete button, I want the task to be deleted from the screen and deleted from the database as well. The database will be created during the second session. So for now, I'll just show you how to create the front. Okay. So we can now start with creating our input field. So whenever you have input fields, what you would want to use in Flutter is something called a text editing controller. And what a text editing controller is it's a class in the Flutter framework, and it's going to allow us to control a text field or a text form field. So with this, you will actually be able to programmatically control the values within that text. So you can control the text that's displayed in that field and retrieve the user's input. So with this, we're going to be able to control the field in which our user is entering their task. So let's call it a new task controller. And you simply have to call the text editing controller construct. Yeah. And now we can start by actually building the field that's going to be shown. So let's think a bit about how our UI is going to be laid out. So what I'm thinking right now is that we're going to have a task input field over here where the user can enter their tasks. And then below that, I want to be able to display all of the tasks that have already been created. Now, if you want to do something like this, you want all the elements to be arranged vertically. So for that, what you're going to need is a column widget. So the column widget will allow you to build a vertical array of widgets. So you can start by simply creating a column widget. And over here, you can add the children. And as I mentioned, the children is going to be an array, which is going to be an array of the vertically arranged widgets that you want to show. So I am now going to add an expanded. So what an expanded widget does is, so the expanded widget is used so that anything within the expanded widget is going to take up the remaining space in its parent widget. So it's usually used inside a row or a column widget to indicate that this specific child of the column should expand to fill up any remaining space within that column. So since I want the task, the input field to go across like this, I'm going to use an expanded widget. And over here, I am going to add our child, which is going to be our text form field. And within that text form field, so this is the widget that you use whenever you're creating an input field. You can simply hover over it, and it will show you all the values that it can take. So as you can see here, it takes in a text editing controller, which is what we declared over here. So you can simply go controller and pass in our new task. So now this will take on the responsibility of controlling our the text that is inputted by the user or any values that the user puts. So we can also add some. I want the input field to say something like new task. So what I'm going to do is add a decoration. So if you hover over this, you can see that it also takes in the decoration widget, which returns an input decoration. So you really don't have to memorize all of this because there are hundreds of widgets and hundreds of parameters that they can take. Just hover over them or go to the widget catalog page and read up a bit about them for example. So as they told me, it's going to take an input decoration. And here is where we can actually add our decorations or whatever we want for our text. So we're going to add a label text. And let's call it new task. And we've gotten a bunch done now. So let's just see how it looks. So this is simply a separate widget. We haven't actually linked it to the main page yet. And how you do that would be in your main.dart file. Within your scaffold, you can actually add a body. So you can go body, and here is where you would pass in whatever you want to display. So what I called it was a task object. And that's all you have. You will have to import this in. Sorry, tasks. Yeah, and you can easily import it in VS Code by just clicking the quick fix and import it. Okay, so now you can save these two files and it should show up in your main.doc file. Once you save it. So this is the hot reload picture. Yeah, so there is our input field. I wanted to have curved borders, so we can add a, within this decoration field, we can add a border. You can see what it takes in over here. I'm just going to go with an outline with border. And it should make these curved. I don't know if you'll be able to see it, but yeah, so here you can see that it's added a slight border. So we should add some padding around this to allow us to see it better. However, if I want to add padding around this whole thing, which means that I'm going to have to nest this whole thing. So I'm going to have to add a padding and wrap this whole column within it. So this can get confusing when you're developing, especially since widget trees tend to get really long and complicated. And there's also all these trailing brackets. So something that you can do in VS Code, which is really useful, is you can get it to wrap the widgets for you. So for example, over here, I want to wrap my column widget in padding, right? So all I have to do is right click, refactor, and then it will give you a bunch of options to wrap it in. So even if the widget that you want is not shown here, you can simply do wrap with widget and then specify what is the name of your widget exactly. So padding is here since it's pretty common to do this. So we can just simply click wrap with padding and it's going to wrap it for us. It's going to add the padding field and say this whole thing is the padding child. So I want this edge insets.all basically means it's adding borders around the whole widget. I want this to be 20 pixels. Okay. And there you go. The padding has been applied now. So we're done with our task input field. Now I want to add the add button over here. So basically what I want is, I want it to be right next to this, which means that I want them to be aligned in a row, right? So this means that I actually have to wrap this within a row widget. So this expanded widget should actually be wrapped within a row widget to allow us to display this task field, the task input field, and the add button next to each other in a vertical array. So we can do that again. Wrap with row. And that should be fine. Now what I want to do is within the row, I'm going to add my add widget right next to it. So I want it to be within my row, so we're going to add it over here. So let me just add the elevated button, which is what the button is called here. We can add a style to it, which will allow us to simply style the button. This itself takes in a button style widget. So we can set the background color using this. This should be within my button style. So background color is a parameter of button style. You can see that over here where it says background color. You can also see over here that the background color should be a material state. So what exactly is a material state property? So a material state property is a class in the Flutter framework that defines properties that you can use to set the visual appearance of a widget based on the current state of that widget. So for example, with buttons, they can have multiple states. For example, when you hover over them, that's a state. When you've already clicked it, that's a state. So material state property allows you to say, when this is the particular state of the widget, I want it to show this color. When it's this particular state, I want you to show a different color. So this allows us to set the visual appearance of our widget based on what is the current state of that widget. So I want it to be the same color regardless of whatever state my button is. So I can simply do .all. And this means that the background color of my widget is going to be the same, irrespective of whatever is the state of the button. So I can set it to colors dot, let's go with an ampersand. We can also set our foreground color, which is what you would use in buttons to specify the color of the text, or basically the color of whatever is the child of the button, which usually is going to be a text. So it's the same thing. Material state property. I will also set this to all and set it. So you can see that we seem to be getting an error here. So you can simply hover over this and see if you're getting an error here, just check if you've added all of the required fields. So for this elevated button, we're required to specify what happens when the button is pressed, and also what are the child widgets of this button. So we can add our child widget over here, which is basically just going to be a text that says add. So we can add a text widget saying add. And we also need our onPressed method. So this is going to tell us what happens once we press the widget. If you hover over this, you can see that it returns a function. So this is a function of what will happen. This is a function that is called whenever you press the button. So we can just declare an anonymous function over here, which is done with the brackets and curly braces. Within here is where we're going to say what we want. So what we want to happen eventually is that when we click the add button, we want this task to go and be saved in our database. So for now, since we don't have our backend service created yet, what I'm simply going to do is print. And this is how you print in Flutter. You just write print. And I want to print the text that the user puts in. And this is where we can use our task controller. So to be able to get this text, we can simply go new task controller .text, and that's going to give us our text, which we can print. So once the user clicks the add button, I also want it to be cleared from here. So you can go new task controller. And if you put this, you can see what you can do. Here we have the clear function. So I'm going to go here. This. Okay, so we can now try saving it and see if this actually works. Yeah. So here is our add button. So if I click this, so if I write something like, and I'm going to add it, and as you can see, it gets printed over here, so we know our button is working, and also it gets cleared from this. So I want to add some spacing between my field and my add button. I can add some padding, but what we'll do is we'll add a box over here just to show you that there are different ways to do this. So over here, right before my button, I am going to add what's called a size box. And we can set this width to be 10. And what's happening here is that we're just adding a small box between these two, which allows us to, which appears to us as a space. Okay. So now we can move on to adding our list of tasks that are going to be displayed over here. So I want to start by adding some padding around them, just so I don't need to wrap it again. So we are going to put it within our column widget because I want them all to be displayed below over here. So we'll start with some padding because I want each task that I'm showing to be separated. So we'll add a padding widget over here. Specify how much we want to add. You can use edge insets dot. Let's use dot only. So this allows us to specify which side of the widget we want to add. So when we use dot only, I can say I only want to pad the bottom. So let's pad the top with 20 pixels. Okay. And then I want to display each of the completed tasks within a box. So we can create, as we used previously, the child is going to be a sized box. We can then specify the size of our box. And I want to specify the height of my box. And in order to do that, I want the box that I'm going to show my widgets in, my task widgets in, to take up about 60% of the screen. So I want the height to be about 60% of the total screen height, just so that it's going to be shown right over here. So how I can do this is I can simply do media query dot of context dot size. Okay, now what does this do? So this line right here is used to get the height of our screen. And we can then multiply it by 0.6 so that we can get a height that is 60% of the total screen. What this context is basically the build context that we keep talking about, which just shows us where in our tree this specific widget is located, which is what we're going to pass here to allow us to get the height of the screen. What I want to do now is the child of my box is going to be something called a list view dot builder. So basically what we're going to have essentially is a list of tasks over here. And to use that, we can use Flutter's functionality, which is called a list view dot builder, which is going to allow us to create each individual item of the list. So you can hover over this and see what we need. So what I am going to add is the item count firstly. Now, since we don't have our database built and our backend, which is going to be storing our tasks, I am simply going to just create one of them to show you guys. And then later on, we will be using some Flutter functionality such as the future builder and the Flask backend. And we will show you how you can actually get these tasks from our service and render it out. So for now, we're just going to set our item count to 1 so that we can just show them one item. Okay. Next, what we have and what we use is an item builder. This is a parameter of the list_view.builder widget. And what this does is if you hover over this, it's going to return a function. And it also shows you the parameters that it takes. So what you're going to put here is the context and I, which I'm going to explain it a bit. So this is just a anonymous function, right? So, well, actually, item builder is a callback function, and this is used in the list_view.builder widget. So this item builder function is actually used to build the children of our list view. So this function that we're specifying over here is going to be called for each item of our list. So for each individual task that we're going to display here, this particular function is going to be called for each of those. Now, what are these parameters? So CTX is short for context. This thing right here, which we've seen a lot. So the context is the build context of our parent widget. So this is going to allow us to obtain any information about the location of our widget in our widget tree. And we can use this to build, and like the location of our widget will allow us to build any scaffolds or themes or any widget that we want. So what I'm going to do here is again start off with the padding widget. And I am going to set it to, I'm going to add now padding to the bottom. So since there are a bunch of individual list tiles, so to speak, the padding is going to be only at the bottom. So it's going to be, since it's a list, it's going to look like it's padded all the way through. So I'm going to do edge insets. And we're only going to set the bottom to 10 pixels. So we can now add the child, which is going to be, as I mentioned, list tiles. So list tiles are what we use to display the individual tasks. So you can simply go list tile, which is in itself a widget. We can specify the tile color, which I'm going to go for a gray. We can go, which is black 12. And let's save this and have a look at it. Yeah, so here is what we've got. It's just a simple gray color box. So next what I want is I want a checkbox over here and a delete icon over here. So in order to do that, our list tile widget has some functionality that we can use. So what we can do is we can use the leading character. And here we can specify an icon, which is going to be a checkbox. So it's going to be a checkbox widget. And over here, we can set the value to whatever we want. So the value is going to be either true or false, with true indicating that it's been ticked and false indicating that it has not been. So we're going to start off with setting it to true. We're also going to have a color, which if you hover over this is called active color, which we are going to set to purple. And you can see that we are going to require the onChanged attribute, which is pretty similar to, onPressed from a button, which we always need. So the onChanged attribute. And as you can see, it expects a function with a Boolean parameter. So what this Boolean parameter is basically, once you click it, what's the value of our checkbox? Are we unclicking it so that it's false? Are we clicking it so that it's true? So you can simply pass in new value over here. And this is going to be the new value that the checkbox takes on once you click it. So if it's currently set to true, once we click it, false is going to be passed over here. We can then declare our anonymous function of what happens once this is ticked or unticked. So what I want at the end, what we want to happen is that once it's ticked, we want the is executed variable to change within our database so that we know that this task has been executed. But for now, since we don't have the database, let's just print executed. And just so that you guys can get an understanding of what this new value is, let's just print that as put that to a string. So let's save this and check it out. So as you can see, that's working. As we click it, executed is false. Since it's initially set to true, once we click it, we're going to get false over here. So this is working fine. We're just printing something. I also want to add the name of the task here. So we will be getting the name of this task from our database through our backend service. For now, we are just simply going to hard code this thing. So we're going to set our title to be a text widget that could be something like finish to do. And as I mentioned, I also want to display a delete icon over here. So in order to do that, what we used for the checkbox was a deleting of our list tile. And what we can use if we want to put it on the end is the trailing card. So here again, you can specify an icon button. So this means that we're turning the bin that we're going to show into a button. So you can do this using the icon button. Here you can simply pass in your icon. Which is an icon widget. And you can now actually get a delete icon. So this is going to come from our material.dart import that we specified at the top. So you can immediately get a delete function, a delete icon over here. And we can set the color to red. Of course, in the button, we do need the onPressed parameter, which is going to return a function telling us what happens when we press it. Again, what we want to happen is that it's going to be deleted from the database. But for now, since we don't have our backend service working, we're going to simply print task deleted. And another thing that you can add as well is that we don't need it in this specific app since it's not going to do anything. But with list tiles, a really cool functionality is that you can simply tap the list tile and you can get it to do something. For example, if you have a list that you want each item in the list to take you to a different page, for example, you can add something called an on tap attribute, which is sort of similar to the on pressed attribute, except that this is actually for the entire list type. So we don't really want to do anything. So let's just have an empty function over here, but I'm just showing you this so that you can use it later on. If you were creating a list that you want something to happen every time you click on the list. Okay, and there we have it. So this is our, as you can see, since I've specified the on tap attribute, once you hover over it, you can tap it. It doesn't do anything since I haven't actually passed a function, but you get this dynamic nature of the mouse where it looks like you can tap. Okay, let's also check out this delete button. Yep, task deleted, so that works. So for now, it's just one task which we've added here. You can actually change the item count. And as I mentioned, this item builder function, it's going to be called for each individual list tile. So if I just change the count to 2, you're going to see 2 identical list tiles. And this is how all our tasks are going to look. So once we build our backend service, we are going to be able to get all that tasks. We can specify the item count, and we'll be able to use the item builder to build each of these individual list tiles into separate list tiles, which can be shown to the user. So for now, this is our really simple front end. It does not do much since it's just a front end, but during the next workshop, we will show you how to integrate this front end that we've built with Flutter into a Flask backend service, which we will create during the second workshop as well. So this is it for our front end. Yeah, I'll now check out some of the questions on Slido. Okay, so someone asked, so I added 10 dp for the size box. How will that be resized when the screen gets bigger or smaller? So we can actually check that out. So it is going to resize for us. I don't know if you can see this. I should have shared my whole screen. This is controlled by Flutter, so we don't really have to worry about it. And even if you're, as I showed you that functionality before, where it was edge, where we're able to resize the screen, even if there's a keyboard. So that is a functionality that will allow us to control all the sizing of this. But even without that, if we're simply resizing our page, Flutter is still going to control that for us. So it's going to change it accordingly. Can you do breakpoints for Flutter like in CSS? I do not think you can. You can probably add it in VS Code, but since this is just a front end, it's not exactly like you can't really pause it, I believe. So I've never actually used breakpoints in Flutter, but since it's just front end, I don't really need to. Debugging, I would usually do with Flutter by using the Flutter. There's actually a Flutter extension, which will allow you to view your widget tree more easier. I don't know if I have it installed right now, but there are a bunch of extensions which can help you with debugging these complex widget trees. I personally have never used breakpoints, so I'm not entirely sure about that, but I don't think it's something that is provided by Flutter, but I will have to check that out. Can we use Java in Flutter? Flutter uses the Dart language. I have never tried it with Java, so I'm not sure about that. And also, just for your information, we will be sending a document with all of this. We will be sending a document, which is sort of like a written tutorial for this. We will also be sending you the code, so you can try this along after the session. Are there any more questions? What is possible to build iOS app? Are you asking, is it possible to build iOS app without Cupertino? What is possible to build? With Flutter, you can, with Flutter, you don't, you can use the Flutter widgets. And within Flutter, you can actually get Cupertino widgets by simply saying there's functionality that will allow you to get the Cupertino widgets directly into your Flutter app. And this is how you specify. So in your code, if you want this app to be able to run on iOS as well as Android, you can simply say there's a bit of logic there. But basically the gist of it is that you say, if the OS is iOS, then I want you to render these widgets. Else, render these widgets. And then you can pass Cupertino or Material app widgets into that yourself. I hope that answers your question. Oh, there's a few questions. Okay, so this app can actually be, if you want to build this app for a device, like for for a mobile, you can actually check out how this will look on a device by using the Android Studio app. So you can get an emulator and it's going to sort of resize and look like this on your emulator. So you can also test out how this app is going to look like on a device. And then this is the web version. Would I recommend building this directly with HTML and CSS? I personally would not want to do that because I'm going to have to, it's going to take a lot of time to hand build all of these widgets using just HTML and CSS, which is why I mentioned that the use of Flutter widgets makes it a lot more easier to build these apps quite fast. I'm not a Firebase expert, but you should be able to use, but Flutter should not be restricted to, Firebase should not restrict it to just Flutter. So I believe you should be able to use it with other frameworks, not only Flutter. Yeah, so Flutter allows you to complete it in different platforms. So you can just use a Flutter Dart file. And there's a bunch of, if you look at the files here, the files that were given to you directly, there's an Android file and an iOS file. So these will actually help you be able to display it on different platforms. So it is possible to create a Flutter app that runs on iOS using just the Dart files. If that is all the questions, then Regan, I think you can wrap it up from here if there are no more questions.
Yeah, okay, sure. So thank you, everyone. Before we end it, I have some few announcements to make. So regarding the questions about like where can we get the slides, and is there going to be like a recording given? Yeah. So you can stay tuned for the post-event email. So it's scheduled around 10:20 p.m. So you receive two emails, one directly a feedback email directly from GDSC, our GDSC community site, so you can give feedback there, and another email which will link the workshop slides as well as like the code along session notes, so that you can follow to code along directly through the document, and you can take a look at the slides. And also in the email would be this post-event form. So this is also according to our university's protocol. So we would like everyone to, help in filling this, which is also like basic feedback information about what we can improve and such. And for the as Zaima mentioned, this is like there's a follow-up workshop for this that integrates this Flutter to-do app with the backend, which is under Flask using Python. So if you guys are interested in that backend, you can register through the link in the chat right now, or you can just scan this QR code. And as for the recording for this video, you can catch it. Once we get all the recording process and sorted out, we will post it on our GDSC Monash University Malaysia YouTube account, and we will announce it on all our social media, so you can look forward to that in the future. As for, I look at the chat, someone's asking for the source code. So there will be like a Git repository. So before the Flask workshop, like probably a day or two before, we will send an email out with all the Git repositories. Maybe we'll release it earlier, maybe not, maybe a few weeks before, or as soon as we can get the Git repository out, we will release it to everyone. And so it'll be under your email as well. So you can just stay tuned for that. So before we end this, I would like to request everyone, if it's possible and if it's convenient for you, to turn on your camera so that we can take a quick group photo for like not marketing, but promoting purposes. So if it's possible, can everyone, open your cam, say hello. Give me a sec. Okay, so everyone, if you're convenient, you can just turn on your camera. If not, I'll just take a photo right now. Okay, sure. Okay, thank you so much, everyone. So that's it for today's workshop. So if you have any criticism or any compliments, you can just say in the feedback. We always welcome any constructive criticism. And if you're interested in our future workshops, please register with our GDSE community page. And if you're interested in our future Flask workshop, you can register that on our community page as well. So thank you everyone who attended and stayed until the very last moments. And yeah, so I'll see you guys in the next 2 weeks from now. Bye everyone.
Thanks, everyone. Bye.
Thanks, everyone, guys. Bye bye.
Thank you guys. Bye bye.